So let's have a look at worksheet B, question number 4. So these are the questions. Now, before we start this question, first thing we need to understand is when we got a function, let's say is y, when we write a function y is, let's say, is 2x, just for explanation, 2x cubed plus 7x. This can also be, y is also written as f of x as well. Yeah, it's same. I haven't differentiated. Y is same as f of x. So that's another thing of writing it down. Yeah, because a function of x. If it's like that, if I go to a next frame, if let's say I got another function, let's say y equals 2t cube, then I can, instead of y, I can write down f of t, function of t, is equal to t cube. Yeah, so they are the same thing, because when you plot a table in your calculator, you just write the same way. That's how you write it down, because f of x instead of y. Okay, now another thing, when we actually have a look at differentiation, first time we differentiate, we get dy over dx, which is also written as f dash x. They are the same way. If I do a second differential, it's d over dx of this thing, dy over dx. I'm just differentiating it again. This thing will become equal d square y over dx whole square, but I'll just write it that way. It's also written as f dash dash x. That's a second differential. Third differential, there will be more dashes. Yeah, another dash. Now the question 4 is find the f dash x. We need to find the f dash x here, which is the differentiation of that one. So what I'm going to do is, I'm just going to differentiate both sides with respect to x. So I will write it down. Differentiate with respect to x on both sides. So when I differentiate this thing, that side will become straight away f dash x, and this one, let's differentiate it properly, d over dx of the whole thing, 2 minus 7x minus 1 plus x to the power minus, this is 8 over 3, minus 8 over 3. How we differentiate that bit? So I'm just going to differentiate each and every one individually. D over dx of 2 minus d over dx of 7x minus 1 plus d over dx of x to the power minus 8 over 3. Once I got that bit, I need to differentiate. So on this side, it's f dash of x. When I differentiate that one, differentiation of a constant is 0. So that will be a 0. Minus, now the rule for differentiation is the 7 comes out, and you're going to differentiate d over dx of x to the power minus 1. Plus, when you differentiate this one, actually, let me write this one down and I differentiate this in the next step. Okay, so if I go to the next slide, okay, if I copy this bit down, f dash x, the 0, I just make the 0 disappear, and then I'm just going to copy that one. So I got minus 7 d over dx of x to the power minus 1, and then I got plus d over dx over dx of x to the power minus 8 over 3. The rule states, minus 7 is there. The rule states this minus 1 comes out, so I'm putting minus 1 in bracket and reduce the power of minus 1 by x by minus 1. So minus 1 plus, according to that one, the rule states power comes out, so this thing is going to come out. Minus, I put the bracket, so minus 8 over 3, and reduce the power by minus 1. So minus 8 over 3 minus 1. Let's do that one. So minus 7 times minus 1 is going to be just a 7. X to the power minus 2. That is a plus and that's minus. So that will give me minus 8 over 3. And then I got x. So minus 8 over 3 minus 1 is going to be minus 11 over 3. And this is going to be your answer. Okay, now why minus 8 over 3 minus 1 is 11 over 3? Because this is minus 1, and to do that one, I cannot add them straight in my head, so I need to make the denominator same. So instead of this one, I can call it minus 8 over 3 and minus 3 over 3, because 3 over 3 is still a 1. And now because the denominators are same, the lower values are same, I can just deal with the top values, and top values are minus 8 minus 3. Hence that will give me minus 11 over 3.